Okay, geometry students, today in lesson 3 we're talking about biconditionals. In lesson 2 we talked about conditionals. Today we're adding on to that with a quick little lesson on biconditional statements. So I guess what is a biconditional statement? Well, a biconditional statement. Remember a conditional statement, so a conditional was in the form of if, then. The if part was the hypothesis, and the then part was the conclusion. That was the general form for a conditional. Well, a biconditional is in the form A. Here we won't use A. We'll use something P, and then if and only if Q. Okay, so this IFF is actually the legitimate symbol for the phrase if and only if. And here's what it means. It means that if you had a original conditional is true, the conditional is true, and the converse is also true. Okay, so if you have a situation where the conditional is true and the converse is true, well, that is going to make a biconditional. And if that's the case, not only can I read it frontwards, if this, then that, and that's true, well, then I can write the converse. If the conclusion is true, then the hypothesis is true. And so we rewrite it, P, and then so the hypothesis without the if and only if in the middle, and then Q. There is no then, there is no if in a biconditional statement. When we write it, it's just P, if and only if Q. All right, now what is a good definition? A good definition is something, okay, or a definition, a statement that can be written as a biconditional. Okay, so if you can write it as a biconditional is a good definition of something. So that's kind of how we're going to define that. So example 1, write the converse, and then it asks, is the converse also true? And if that's the case, write it as a biconditional. So here we have a statement that says, if the sum of the measures of two angles is 90 degrees, then the angles are complementary. So we will flip this around. There's a conditional. The converse would be if, oops, the converse if angles are complementary, then the sum is 90 degrees. Okay, so here is my converse. Let's see, is the converse also true? If I have two angles that are complementary, will their sum be 90 degrees? And the answer to that is yes. And so let's write this as a biconditional. So we'll go back to the original conditional here, although it would be possible to stick with this one. We'll say we're going to get rid of the if. Okay, so no ifs, no thens, and we'll just say the sum of two angles is 90 degrees, And then here's the key, IFF. If and only if the angles are complementary. Okay? And this is a biconditional statement. It covers both directions. All right, so there's a biconditional statement. Let's see, write the two conditional statements from this biconditional. So Kennedy can dunk a basketball if and only if she is athletic. Okay, so I'm going to write this as the conditional and the biconditional. If, oops, I guess the first one we're going to have to put the if and the then back in there. So if Kennedy can dunk, then she is athletic. Okay, so if Kennedy can dunk, then she is athletic. That would be this biconditional broken down into a conditional. And then the biconditional, the other direction. If, and again, I need to have the subject in my first part here. So if Kennedy is athletic, well, then she can dunk. Okay, so there is taking a biconditional and then breaking it down into two conditionals. All right, last one I believe here. We take a look at it. So which of the following statements are good definitions? Dogs are animals with four paws. Well, can I write this as a biconditional? Can I write this where the conditional is true and the converse is true? So if an animal is a dog, then it has four paws. If an animal has four paws, then it's a dog. Well, the first one is true. The conditional is true. If a dog is an animal, then it has four paws. But the other way, I can think of lots of animals that have four paws that aren't dogs. And so I would say, no, this one is not a good definition. Okay, it's just not specific enough. Squares have four sides. So again, let's see. If a shape is a square, then it has four sides. Okay? If a shape has four sides, then it is a square. Nope, that's not true. And so, no, this is not a good definition because only the conditional is true. The converse is not. Tuesday is the day before Wednesday. So if a day is Tuesday, then it is the day before Wednesday. Okay? If a day is Wednesday, then it is the day before Tuesday? No. An acute angle has a small measure. Okay, so if an angle is acute, then it has a small measure. Okay, I'll buy that. If an angle has a small measure, then it is acute. Yep, that's true also. Okay, so D is my winner here. This one has a good definition because both the conditional and the converse are true. All right, so here's your set of exercises for today. Problem solving, do number 47.